Welcome to week two and my technology challenge to create a new innovative home safety product locally to create new jobs in the local area and try and stimulate new economic growth and activity for us all. This update is more about what I've been doing over the last week in terms of finding and talking to local manufacturers, and I've been quite surprised of how many good little engineering firms there are scattered around town, when I thought most of them had probably been vanquished decades ago as part of government policy. So they've struggled to survive in little niche corners where the government haven't yet found them. But I'm sure the government will get around to it eventually. This gives me a tremendous opportunity to try and bring all the jobs locally, focus all the work locally, and try and keep all the work, the employment and the opportunity here in the town, which is good for me because it means I can go out and talk to all the guys. It's good for them because hopefully the success of this will allow us to bring some new prosperity back into the community. During my discussions with local workshops, I've been learning that some of them would prefer to have my drawings and my ideas for the innovation laid out in CAD. Now, I don't know if you know what that means. That's called computer aided design, which is basically designing all the parts and all the components of your product in a way that can then be transferred quite quickly and quite easily to the tooling and the manufacturing process. Now, you probably gather that I do know a little bit about computer design for my work on this, but this isn't CAD. This is a technique known as surface modelling. There are actually three different kinds of computer modelling. CAD is all about precision engineering and detailed component design. Surface modelling is similarly accurate. It gives you the size, the shape, the scale, but it's about the contours and the surface and the styling of a product, like automotive design and engineering. At the other end of the scale, you have what might be described as rough modelling, the very rough concept idea, or the more artistic end of the scale. And that's the kind of thing you would see a lot in the CGI field in terms of video games, film and television special effects and all that. That's all so-called mesh modelling. And mesh modelling, I can do a bit of that. I can do the surface modelling, I can't do CAD. Now, mesh modelling will be quite easy, but is never accurate. It's not really disciplined and it's not designed to work with precise engineering measurements. So if you want to design something 3 foot long, you might just be able to get it there. But if you want something 300 foot, like a spaceship, with lots of detail, then you just have to have a rough fudge of a guess. And I'll give you an example of how that works, as it were, in the real world. There was a story I heard a few months ago about one of the TV shows, one of the Star Trek TV shows, I think it was, and they'd created a beautiful new updated rendition of the Starship Enterprise. It was magnificently detailed and it worked brilliantly in all their CGI and their special effects. And they were running a scene where they had one of their Starship shuttles coming to dock, and they found it just about fitted inside the docking bay, which made it look like the size of about 5 houses. In other words, they got the scales wrong. Great mesh model, really beautifully detailed, wonderful special effects, fantastic colour, great textures, looked really pretty, except the space shuttle looked like it was made for 50-foot giants. And so what they had to do in the end was to take the model of the Starship Enterprise, the exterior model, and scale it up so that the space shuttle would fit properly in the little hangar at the back. That's the problem with mesh modelling. Although it's quite good at doing really good special effects, and I'm sure we've all seen and admired all the special effects, whether it's on TV, on film, or in video games, it's not precise enough for you to feed the information into a machine tool to make parts. You could do it with surface modelling. Problem with surface modelling is it just describes the surface. That's the bit on the outside, the colour, the texture and the shape. It doesn't describe all the bits underneath and inside. You can describe all the bits on the inside with mesh modelling, but you wouldn't get the precision. And that's where CAD comes in. Problem with CAD, it's so precise, it's obsessed with the parts. It allows you to design nuts and bolts and screws, and then brackets and joints, and then put the nuts and bolts and screws in the brackets and the joints, and then gradually, slowly assemble the part until you've got some more parts and plug those into an assembly, which then becomes a bit of a machine which then fits into, and after several years of designing all the parts, you might be able to build a small car. Well, it's going to be, I really just don't have that much time. CAD is great for simple assemblies at the moment, and what I've been doing over the last week is just trying to reason out whether or not I should go down the existing route, which is quick mesh modelling, or try and do a surface model of my innovation, or sit down and teach myself the basics of CAD, which is something I've avoided for a very, very long time because of its obsession with parts, whereas I prefer concept designs and the big engineering model. But as I say, the workshops in the area would love CAD. At the moment, I'm just going to have to give them blueprints. I will probably have to start looking at teaching myself CAD, and it's something I would advise anyone, if you ever think about inventing something, CAD is probably the way to go somewhere along the line, unless you just want to stick to mesh modelling for special effects and just the basic concept of surface modelling to get the styling. So that's your lesson for today. The different aspects of computer modelling: CAD, surface, or mesh modelling. What do you want to do? Do you want to design parts? Do you want to design the overall concept? Or do you want to design just a rough artistic model? And now it looks like I'm going to have to learn an entirely new set of skills in terms of refining and perfecting what I already know to get the new innovation and new technology in a position where it can be sent to the factories, sent to the workshops, and fed into their computer operated machines for them to work with precision accuracy down to 1,000th of an inch. So there we are. That's what I've been up to for the last week, and it's probably what I'm going to be up to for the next week or so as I begin turning the ideas, turning the designs and the parts into the finished products. Hopefully that'll be done this week, but we've got a big bank holiday looming, so I'm sure people are going to be taking a very, very long bank holiday, and it'll probably be sometime next week when I'll have more news and information for you. So, hope you're enjoying the challenge. Stay tuned, there'll be more to come. See you.